Good morning. I'm Aaron. I'm a senior at Atkins High School. This past summer, I completed an internship at Wake Forest in the Department of Chemistry, which is located in the Innovation Quarter downtown. You can kind of see it off of Highway 52. The lab I was working in is under faculty Dr. Rebecca Alexander. She's a professor of biochemistry at Wake Forest University. In the lab, I worked with 3 PhD students, another undergraduate intern, and a postdoctoral fellow. So to kind of give an overview of what the lab studies, I'd first like to maybe review, maybe new for some of you, this process known as the central dogma of biology, termed by Francis Crick. So essentially, it's this flow of information from DNA to RNA to a protein. So this starts with DNA, which is in the nucleus of the cell. It's transcribed into mRNA, which leaves the nucleus, and then enters the ribosome, where it's translated into protein. And the lab studies this process of translation. So as mentioned, it takes place in the ribosomes, which are pictured here. And one of the key steps to this process is the entry into the ribosome of this tRNA molecule, which forms a complement with the mRNA strand and deposits an amino acid, which of course are the building blocks of protein. But before translation can ever happen, there's a crucial step that we need to examine. So this pictured is an enzyme known as aminoacyltransferase synthetase, which binds the amino acid to its cognate tRNA molecule. And as you can imagine, this is an incredibly important step in the process because without it, the translation can never occur with any fidelity. So this enzyme essentially reads the tRNA and binds the proper amino acid to it. So this enzyme is what the lab is dedicated to. My project is called a malachite green assay, or a chemical test for the activity of this enzyme. So my task was to replace a radioactive method of assaying for this enzyme, which is both hazardous and very expensive for the lab. So the proposed method, you can kind of see it right, is what's called colorimetric. So essentially, as the enzyme functions over time, there's a buildup of byproduct, and what we can do is take some of that byproduct, react it with a dye, and see over time, as the enzyme progresses, a deeper green color. And through this green color, we can use a device known as a spectrophotometer, which will shine a light through that solution, and then we can quantify the amount of enzyme activity based on that data. Unfortunately, there aren't enough hours in the summer. I was not able to come to a great conclusion to this project. We saw some interference from ATP, which is one of the reactants in this process, and while there are ways to eliminate this problem, I ran out of time, but it was certainly a learning experience and a great experience for me. The other project I worked on is called Evolution in Action. So what this is a lab that I was working to help implement in high school biology classes. So the lab, in essence, is using this bacteria called Pseudomonas fluorescens. And what we do is we take a population of Pseudomonas fluorescens and repeatedly select the most fit bacteria from that population. So this mimics evolution by natural selection as we select the most fit bacteria. And what this lab is really designed to do is to teach students the principles of evolution. So of course, there's the actual lab techniques that they'll use, like bacterial culturing and sterile technique, which, as I saw, are still broadly applicable in high-level biotech positions. But they also will learn the skills of data analysis, so they'll see how this population is changing over time, and then can we kind of make any conclusions about what is evolution's role in this. And this lab was a success, and I really look forward to working to implement it this second semester in high school biology classes. So pictured is the biotech Innovation Quarter downtown, which includes the Department of Chemistry at Wake Forest. It's a pretty cool place. So yeah, in closing, I think I learned a lot in this internship. I mean, obviously lots of bacterial techniques, sterile technique, protein techniques, a lot of which I actually took from my learning in the biotech program at Atkins. And it was pretty interesting to see how much of that is still used in these graduate level positions at Wake Forest. In addition, I saw a side of Winston that I really haven't seen. You know, the City of Innovation is a great slogan, but I learned that it's more than just a slogan. There's obviously great companies here in town, great universities doing a lot of really cool research. So, Winston is not just my lame hometown. There's a lot going on here. It's a great place to be. Thank you so much.